Hello, and welcome to today's daily Leetcode challenge. Today we'll be solving question 1637, widest vertical area between 2 points containing no points. So a bit confusing there, but this is a medium level question. Let's get into the description. Given endpoints on a 2D plane where points I is in itself a length 2 array, return the widest vertical area between 2 points such as no points are inside the area. Alright, our vertical area, so now what is a vertical area? Is affixed with extending infinitely along the y-axis, infinite height. Widest vertical area is the one with the maximum width. Note that the points on the edge of the vertical area are not considered included in the area. So what does that mean? So we have these vertical areas that are infinitely high, and the way that they're defined is by points that are bound to the left and to the right of those areas. So if we were to look at these rectangles, if there was an ability to create another point here, there would be another rectangle connecting the rightmost and the leftmost point here. Okay, so I believe that all we have to do is figure out what is the widest vertical area, translating to what is the widest, what is the maximal difference between 2 points along the x-axis. I believe that's pretty much it. Let's check this with the examples that were given. So the output is 1, and the way that the inputs are 7, 8, 9, 9. 7, 8, 9, 9. Awesome. And the widest area is 1. So the difference between 9 and 8 is 1. The difference between 8 and 7 is 1. So the maximal there is 1. Let's look at example 2. It's a bit more complicated. Let me write this out here maybe. We have ones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 1 here. We have, I'm just trying to visualize this. We have a 3, we have a 5, we have an 8 and a 9. And along the y-axis, the greatest difference, just very visually, is between 8 and 5. So 8 minus 5 is 3, output is 3. So I think that pretty much that's all we have to do, right? We have to figure out what the sorted version of these points are along the x-axis and look at and find the maximal difference. I don't know why this is a medium level question. Let's try doing this. We can sort the points by the key, I believe, is going to be the first element inside of the nested arrays. Let's make sure that that's the case. Always like printing intermediate little steps just to make sure that we're doing everything right. 7, 8, 9, 9 seems sorted enough. Hopefully this one is sorted too. Let's get to the max diff. Let me say that the max diff is initially 0 for I in range. Let's start at 1 and go to length of points. Let's have the first point be points at I minus 1, and the second, let's have it just be at I. Then say max diff is equal to max of max diff, and S 0 minus f 0. What I'm doing here is finding the maximum difference between the existing maximum difference, which is 0, and the 2 points that I'm iterating over. And keep in mind that I'm iterating over all adjacent pairs, returning the max diff. This should be good enough. Let's see if we get the correct answer. We did. Hopefully there are no edge cases. It seems like there aren't. Let's see how we did compared to other solutions. 50th percentile, not bad. Let's look at how others did it. I don't know that function. Sorted lambda, sorted points, we're doing the same thing, we're sorting. Let me check one thing. I would like to see if I can actually sort this by key. Lambda x 0. Let me see if this runs faster. The reason why maybe the default sorting algorithm isn't as easy or as ideal as the one where I specify the key on which I'm going to sort is that it could be comparing it could be comparing the whole array itself. And it does run a bit faster. We're in the 92nd percentile. Okay, so doesn't matter, and I'm guessing that you can do this the previous way as well without specifying the key, but specifying the key reduces the number of comparisons the sort function is doing while sorting. It prevents it from comparing arrays. It now just compares the first integer in each of the array. With that, I think we're good. 92nd percentile, where we have very readable code, and I suggest you use this. Cool. Well, thanks for watching. This was another pretty easy one. Please like and subscribe, and I will see you tomorrow. Bye.